Hello all. Today in this video I'm going to provide a demo for a CNN for image classification and binary image classification. Here we have done. So initially we have imported the libraries which we are needed. So we are moving with TensorFlow only. For that we are working with the TensorFlow library, and also apart from that we have also used Pandas and NumPy library. Then we have imported other libraries which is used in this work in the second cell. In the third cell we are going to make our training and the testing set variables. So for that we are declaring the library image data generator, and then shaping our images, and also declaring the testing set variables. And in that 5, that is cell 5, we are declaring the testing set variable. So here the data set I diverted it from Kaggle, a binary classification file which is for cats and dogs. And then you can see that we are having nearly 8,000 and 1005 images for training and 1023 images for testing. So then we are declaring the libraries which we needed for the convolution CNN, that is convolution convolutional neural network. Only we are going to do this in this work, so that only we have done over here. And then the first initially for the sequential layer we are calling, and then the convolution 2D layer. Here we are calling the filters, then padding, kernel size, activation, strides, and also the input shape. Here we have a reshaped our input as 64 into 64, so that 64 only we are calling over here. Then we are calling the max pool 2D with a pool size of 2 and strides as 2. And also consequently we are calling another convolution layer and also max pooling layer. This convolution layer is also using the same filter size as in first layer. Padding is also same, kernel size is also same as 3, and the activation is ReLU. Then we are just declaring the max pool layer. This is also here the pool size is 2 and strides is 2. Then we are declaring the flatten layer. Then we are calling a dense layer with units as 128 here. Then the final dense layer, which is we are calling for classification. Here you can see we have also regularized a kernel regularizer, because a kernel regularizer will just make an reduce the overfitting and underfitting issues which is found in the deep learning. For that we have used the kernel regularizer. And finally we are calling the summary of our data set. Here the output shape of the data set is declared, and then we are just compiling our model by using the Adam optimizer. And then we are fitting for fitting we are calling the training testing set, and also approaches we have done for 15 approaches. By this you can see the loss, accuracy, validation loss, and validation accuracy. Here you can see notice that for a better system the accuracy should be less when compared to validation accuracy, and also validation loss should be less when compared to loss. So you can notice that this is achieved in our model. So our model is providing only better results. And then we are plotting this loss values and also the validation accuracy value in graph. So from this also you can just confirm that when compared to training accuracy, validation accuracy is providing better results, but when approaches is increasing, it is showing some decrement, but the same wise loss. So this thing we can check in our later videos. And then we are just loading this model into an out cn.save function in h5 file, and then calling by using that. Then we are just testing with some other cat images. So once we are testing, then we are setting to find the images what we have given, whether it is an cat or dog. Since we have given cat, the image is classified as cat. If you want to give it as already we are having some dog images also, so we can rename with this dog image. Dog. So now I'm running this code. So initially you can see the image is classified as cat. Now I'm running this line. So now it is like image is classified as dog. So you can see it is a better system only. Likewise, you can also check with some other trained testing images. By that you can just find out that this model is providing only better results. So in the next video, we will show you some other demo video, and also if you are interested in knowing some other demo video means please make us in the comment box. So if you are aware of it means we will definitely make a video regarding that. Thank you.